Alright guys, it has been a couple days since I've seen you. It has been a very long week, so I'm going to go over one of the homework questions with you guys. Feel free to check my math. I have gotten very little sleep over the last couple days, but we do have a new little girl. I'll show you guys pictures when I get back. This is probably the hardest question on your guys' homework. It's a work function question. It's question number 8. It asks you got pieces of potassium and sodium. It gives you the work functions, and then it tells you that it gets hit by a piece of light, a photon, that has a wavelength of 325 nanometers. So I'm going to go ahead, I'm going to write all that stuff down because that's information that we want to know. So my wavelength is 325 nanometers. So 325 nanometers, that is 325 nanometers is 10 to the negative 9 meters. So we're just going to go ahead and convert that right now because that's going to be more useful. And then my work function, so that's what we're looking, it looks like a circle with an eye through it for potassium. So this is a work function, okay, potassium. For potassium is 3.68 times 10 to the negative 19 joules. And then for sodium, it's 4.41 times 10 to the negative 19 joules. Now, the equation in the book that they give you for a work function, it tells you that the work function is equal to HV. So this is energy. So your energy equals Planck's constant times the frequency minus your kinetic energy of the electron. But the question is asking us which of the metals is going to have a higher velocity when it gets kicked off. So we're actually going to be looking into the kinetic energy. That kinetic energy, the equation for kinetic energy is 1/2 the mass, in this case of the electron. We're going to use U squared. U is just going to be the velocity of that electron. We're going to use U instead of V because V looks a lot like nu, and we don't want to get those mixed up. But this is going to be what we're looking for in the end. So it's going to end up with square root of 2 times your kinetic energy divided by your mass of your electron. And we're going to need to do that for both sodium and potassium. So what we're going to do is we're going to go ahead, we're going to rearrange this equation and just solve it for kinetic energy. So I got my kinetic energy is equal to my energy of the light minus the work function. And that's going to be what we're working with. So we're going to do this equation 2 times, one for potassium, one for sodium. We're going to see which one has the higher velocity. So for first off, we're going to do potassium. So I'm just going to go ahead so I can keep track. Okay, here's potassium. My kinetic energy equal to H as Planck's constant, so 6.626 times 10 to the negative 34. And this is going to be joule seconds times nu. Now nu is frequency. We don't know frequency. We do know that frequency is the speed of light divided by your wavelength. Because remember, wavelength and speed of light are proportional, or not speed of light, wavelength and frequency are proportional. So what we can look at is instead of plugging in some unknown number, we'll go ahead and we're going to plug in the speed of light, so 2.998 times 10 to the 8. Remember, we have become more specific in here. That's going to be meters per second divided by my wavelength, so 325 times 10 to the negative 9. It's going to be meters. Minus my work function for potassium, so 3.68 times 10 to the negative 19. That's joules over there as well. I just don't have room to write it down. Okay, so what we're going to do, go ahead and plug it into your calculator. Hopefully you can see this online. So I'm just using my phone calculator because I don't have any calculators at home. So I got 6.626 EE34. So I got 6, that's Planck's constant. We're going to go ahead and multiply that by the speed of light, so 2.998. So that's that times the speed of light, and then we're going to divide that by 325 So that is what you're going to get for this part right here. Now that's going to be the same part for sodium as well, but I'm still going to want to redo that just because this is going to change. So we're going to go ahead and subtract 3.68 EE19 negative. So you can get 2.43 times 10 to the negative 19. This is our kinetic energy. And that's going to be in joules. Now when we get over here, joules is another way of using the units is kilograms times meters squared over seconds squared. That's going to be how we can make these units actually measure up. So we already did the math up here. Here's my equation. The velocity is going to equal the square root of 2 times my kinetic energy divided by the mass of my electron. So I'm just going to go ahead and plug that straight in. If you want to show your work, go ahead. But if you want to just go ahead and plug it right into this equation, you can. So I'm going to do 2 times 2.43 times 10 to the 19 kilograms per meter squared over second squared divided by the mass of my electron, which is 9.11 times 10 to the negative 31 kilograms. So kilograms is going to cancel out. Once I take the square root, that's going to make this meters squared per second squared just turn into meters per second. But all I'm going to do is I'm going to take the number I got, my kinetic energy, multiply that by 2, divide that by mass of my electron. So you got 5. That's a really big number. Just take your square root. So this is my velocity. It's 730,732, or we're just going to round that to 7.31 times 10 to the 5th meters per second. Okay, so this is my velocity for potassium. Okay, potassium's velocity 7.31 times 10 to the 5th. Okay, now we're going to do the same thing for sodium. So sodium 6.66 times 10 to the negative 34 joules per second, joule seconds. 2.998 times 10 to the 8 meters per second divided by 325 times 10 to the negative 9 meters. A lot of times too, you're going to see this is written as 3.25 times 10 to the negative 7. Just be aware of that. I'm going to subtract the work function, so minus 4.41 times 10 to the negative 19 joules. So we'll go ahead and plug it in. So we got 6.626 34 negative times speed of light divided by my wavelength. That's the same number. Then this time we're just going to go ahead and subtract 4.41. Alright, so that is my velocity, or my kinetic energy this time. So KE 1.71 times 10 to the negative 19. We're not trying to solve for my kinetic energy though, we're solving for my velocity. So U for sodium is going to equal 2 times 1.71 times 10 to the negative 19 kilograms per meter squared second squared divided by my mass of my electron. Now notice I rounded here. In my calculator I haven't rounded yet because we're not at the end. So we're just going to go ahead and multiply that by 2, divide it by my mass of the electron, and then we're going to take the square root. So we got 611,314. So we're just going to round that to 6.11 times 10 to the 5th meters per second. The question asks you which one has a higher velocity. Well, this is your sodium velocity. Then there's your potassium. Potassium is 7.31 times 10 to the 5th. Sodium is 6.11 times 10 to the 5th. So potassium is going to have a greater velocity. And then the other parts of the question are, what are those velocities? So here's one, and there's 2. If you have any questions, just send me an email.